Let's break down number 6 for the AB only for the 2025 released FRQs. And it looks to me like we're dealing with an implicit relation here. Pretty typical, right, of what they've done around this same time, starting after COVID. Show that dy dx is equal to that. All right, again, maybe you want to rewrite this down in the opening of part A in your blue book so that you can organize your thought. I always told my students when you're doing implicit, just put a parenthesis around it, because that just means you're going to chain out a dy dx every time you use that as a derivative in your derivative from left to right. But this one's not too hard. Derivative of this would be 3y squared dy dx. And again, you should be very schooled at taking implicit differentiation or implicit derivatives. This would be a negative 2y dy dx. Negative dy dx. Plus a half x, or x over 2, sorry, equals, be careful, 0. Well, the derivative is 0, 0, so they didn't even make that hard. So you would factor out a dy dx from these three terms. And notice it equals, or the parentheses, a 3y squared minus 2y minus 1. You would subtract the negative x over 2 to the right. And then to finish this, your dy dx would equal, they just put the negative x up top, you have the 2 down here, and then you would divide by the quantity 3y squared minus 2y minus 1. Nothing crazy there. Sorry, this is a little cockeyed. All right, there's a point P on the curve G near 2, negative 1 with x-coordinate of 1.6. Use the line tangent to the curve at 2, negative 1 to approximate the y-coordinate of point P. So they told us the x-coordinate of point P. They want us to do a local linearization using this. So my thought is, okay, this is x, this is y. All right, this is what I want to plug in to get my y-coordinate. So the first thing I need to do is I need to take dy dx, and again, I'm not going to be able to mark up in my blue book. Just be careful. That's something we have to adapt to as the test changes. And again, I'm going to label x, y just so I plug in right. My mind or my eyes always set to what I'm plugging in. Negative x would be negative 2. This would be this bottom or the denominator would be 2 times quantity. Negative 1, quantity squared is 1, so that would be 3 plus 2, be careful, minus 1. That would be a negative 2 all over 8, which would be a negative 1/4. Just kind of do some double checking in your head and make sure you're good to go. Now I'm just going to set up point slope, so that'd be y plus 1. I'm using the tangent line at this point to approximate that value. That's to the left. So y plus 1 equals, my slope would be negative 1/4 all times x minus 2. I would isolate my y. And if you wanted to put like y sub p, maybe, I don't know, I'm just going to leave it as y. Let's subtract the 1 over to the left. Now I'm going to plug in my 1.6, and I'm going to get a negative 0.4 and then minus 1. Now let's think about this. So negative 1/4 times a negative 0.04, right? We would get a 1, but it would be 0.1 if you really think about how that works out. when you divide that by 4. That's kind of easy. The negative, negative wash, 0.1. Kind of do elementary division in your head. You would subtract 1, and you would get a negative 0.9. And then I would just write a sentence using their words. The approximate y-coordinate of point P is negative 0.9. If you wanted to put a 0 on, that'd be fine too. All right, looks good. For positive x values, positive y value, there's a point S on the curve G at which the line tangent to the curve at the point is vertical. Find the y-coordinate of point S. Show the work that leads to your answer. All right, first things first, I would just let them know. I'm looking for an undefined slope for a vertical slope, so I would let them know that dy dx is undefined. When 3y squared, I just need the parenthesis to be 0. 2 is never going to be 0, multiplying to that. So when 3y squared minus 2y minus 1 is equal to 0. All right. Now, off to the side, I would factor that, because that would give me a 3y and a y. Set it equal to 0. I have a negative 2y here, so I need a negative 1 here, plus 1 here. So I know that the bottom would be 0, or the denominator would be 0 of my slope, if y were a negative 1/3 and 1. But I don't need negative y values, right? I'm done. This occurs at y is equal to 1 for y greater than 0. The y-coordinate I'm just kind of logic, it's just a flow of logic using their words now. So the y-coordinate of point S is 1. They've already oh, sorry. I'll just put 1. So that should be good to go. So a particle moves along the curve H, defined by the equation here, at the instant when the particle is at 4, 1, so that's my x, y, and you'd probably want to write down that on your opening in your blue book for part D. Put this down there too, dx dt is 3. It says find dy dt at that instant, and then show the work that leads to this answer. This is just, what, a related rate, right? So what you need to do, sorry, it's this one right here. You need to take the derivative of this equation or this relation you can probably write that down. And again, just be careful. I'm showing this because I can see the product rule already is needed to implicitly take the derivative of this equation with respect to time. And again, we gotta adapt to the blue book way of doing our FRQs, right? So we're gonna have to maybe write our equations down sometimes and label them, or put some things off to the side to kind of organize our thought a little bit, but you can practice that. Now remember, every variable you have to chain out with respect to t, a derivative. So this would be product rule, 2 dx dt all times y plus dy dt all times 2x. Now be careful here. Plus dy dt all over y is equal to 0. All right, so that's how you want to take the derivative of this equation with respect to time implicitly. Now let's plug in the values we know. So this would be 2. dx dt is 3. My y value is 1. Again, I'm trying to find my dy dt. My x value is 4, so that would be 8. Now this would just be dy dt over 1, so this would just be dy dt equals 0. That means I have 9 dy dt is equal to, that would be 6, so I'd subtract 6 to the other side. Isolate my dy dt, and that would give me a negative 2/3. So that's it. I thought this was a pretty reasonable test. I don't know how you felt about it. Those of you studying for the future, you can kind of see now, this is the first time that we can see how would you do this if a blue book with just open spaces labeled with the number and letters on it were there. Again, there's no shortcut into knowing all of the fundamentals. We can adapt to the blue book way of doing things. And I think they kind of made it a little bit better with the way they kind of formatted and asked questions. They adapted. So hopefully this helped you out. Good luck.